Hand-rolled agent loops get messy fast once tools call tools. I'll build the same workflow in Python with the OpenAI Responses API, so tool calling stays stateful and simpler to ship. This is the shape your solution will take when we finish, which auto-selects and runs the right tools to convert units and calculate totals. I'm Professor Pi, teaching AI engineering and LLM systems with simple Python. Think of the common problem where a model must reach out to external helpers, gather structured results, and then continue reasoning. People often build manual agent loops that call tools, parse results, and rerun prompts. That approach works at first, and then becomes a tangle when tools call tools, and you need consistent state. The OpenAI Responses API provides a cleaner pattern. It returns structured actions and accepts tool outputs, so the model can pause for a function and then resume, all without a fragile manual loop. At a high level, we want 3 things. 1. Confirm the client is connected and produce a short text reply. 2. Run a reliable code execution for numeric work and get machine-readable JSON back. 3. Wire real function calls into the loop so tools can be invoked and their outputs fed back. That is what we will build step by step. We will build a minimal demo that shows a small text reply, a code-backed calculation, a simple function tool call, a deterministic force toolpath, and finally a chain that mixes our function with the built-in code interpreter to compute a total after tax. These are small and composable, so you can apply them to unit conversion, pricing, or inventory checks without rewriting the agent. Now, let's make a minimal API call and preview the model output. This snippet makes a minimal request to the OpenAI Responses API and shows a short preview of the model's reply. It creates an OpenAI client, selects a lightweight model, and prepares a concise prompt. The call to client responses sends the input and returns a structured response object. The variable R holds the entire result, and R output text provides the consolidated text from the response. The code then slices the first 40 characters into preview to keep on-screen output compact. For lower latency and cost, prefer smaller models for simple tasks. The printed preview confirms the client is connected and producing useful text. Next, we'll ask the model to run precise calculations and return strict JSON. This example uses the OpenAI Responses API with the built-in code interpreter to perform a precise calculation. The task string asks the model to compute a mean and standard deviation and to return strictly formatted JSON. The call to client responses creates tools with a code interpreter entry and a response format that enforces a JSON object. The response object's text is parsed with the JSON loads function into the data variable, extracting numeric fields safely. Lowering the number of values reduces compute time. Adding more values may increase accuracy, but also cost. The printed mean and standard deviation show the tool executed code and returned machine parsable results. Now we'll demonstrate a function tool that the model can call and then resume from. This code demonstrates OpenAI Responses API function calling without writing a manual agent loop. The GWTools variable defines a function tool named getWeather that accepts a city. The first client responses create call asks the model to use that tool. The response object includes required action with a tool calls list. The variable TC references the tool call and its arguments, while out holds our tool's computed JSON result. The call to client responses submit tool outputs, sends that output back, and the API continues the reasoning steps automatically. The final text in our output text reflects the model's completion using the tool's data. The printed JSON confirms the toolpath worked end to end. Next, we'll lock the model into a deterministic tool choice for repeatable outputs. This snippet forces deterministic tool behavior with the OpenAI Responses API for reliability. The LQTools variable defines a list quotes function that takes an item. The call to client responses creates sets tool choice to the function name, ensuring the model must call it, and uses temperature 0 to reduce randomness. The API returns a required action. TC captures the tool call, so we can return our quotes via out. After client responses submit tool outputs, the model finalizes with a compact JSON answer. Lower temperature reduces variance, but can make language less expressive. The printed winner shows the model selected the cheaper quote as intended. Finally, we'll compose a function call and the code interpreter so the system both fetches data and computes tax. This example chains a custom function and the built-in code interpreter using the OpenAI Responses API. The Tools To list combines LQTools with a code interpreter entry. The request asks the model to fetch a price via list quotes and then compute tax in the sandboxed interpreter, with response format enforcing JSON output. The API first returns required action for the function call. TC captures it, and ALP supplies the quote. After client responses submit tool outputs, the model continues automatically and executes code to add 8% tax. Increasing the list size or tax rate raises compute and tokens. The printed total shows the final computed amount after tax. Taken together, this demo shows a compact pattern. What it is: a stateful tool calling flow using the Responses API that pauses for functions or code and then resumes. When to use it: when your model needs reliable external data or precise calculations without brittle hand-coded loops. One caveat: more tools and heavier code increase tokens and runtime cost, so measure latency and spend. For the next step, evaluate this pipeline at modest scale by running it on a larger set of inputs and adding timing and accuracy checks to find bottlenecks. If short, practical AI engineering helps, subscribe and watch the AI engineering videos.